Hello there and welcome to today's class. In today's class, we'll be solving over 10 most repeated Post UTME questions on physics. The first question we have on the board says, a stone is thrown upwards at an initial velocity of 20 meters per second from the top of a 45 meters tower. Take g, which is acceleration to gravity, to be 10 meters per second squares downwards. How long before it hit the ground? How long before it hits the ground? Option A, 5.0 seconds. B, 5.6 seconds. C, 6.5 seconds. And D, 7.2 seconds. Now let's write out the given parameters. Solution. From the question, we are given what? Initial velocity u to be 20 meters per second from the top of a 45 meters tower. So the displacement here is what? 45 meters from the top of a tower. Take g, acceleration to gravity, to be 10 meters per second downwards. Here we have acceleration A is 10 meters per second. Now, note that upward motion is positive, while downward motion is negative. So we have upward motion to be positive and downward motion to be negative. Here it says a stone is thrown upwards, so the initial velocity here is positive since it's going upwards. Displacement here is downwards, and acceleration to gravity is also what? Downwards from the question. Recall the law of motion that says S is equal to ut plus 1 over 2 at squared, where S here is displacement. If we substitute these values into this equation, we have that S, the displacement, is what? Minus 45 meters is equal to u times t. Our u here, the initial velocity is 20 meters per second times t, we don't know t, so we say t plus 1 over 2 at squared. A from the question is negative 10. That's acceleration to gravity. T here is unknown, so we have t squared. This is the same thing as minus 45 is equal to 20 times t gives us 20t plus 1 over 2 times minus 10. It's the same thing as 1 times 10 will give us minus 10 over 2t squared. Now from here we have that minus 45 is equal to what? 20t minus 10 divided by 2 gives us what? 5t squared. Now we have minus 45 is equal to 20t minus 5t squared. Here, if you transform this to a quadratic equation, you have that. You move all these to this side of the equation, we have 5t squared. When negative 5t squared crosses the equality sign, it changes from negative to positive. So we have positive 5t squared. 20 here crosses. When 20t crosses the equality sign, it changes from what? Positive to negative. So you have minus 20t minus 45 is equal to 0. Looking at this is a typical quadratic equation where the highest power of the unknown is what? 2. If we divide through by 5, we have this divided by 5, this divided by 5, and this divided by 5. We have It will cancel out, so left with t squared minus 5 goes into 5, we have 1. 5 into 20, we have 4, so we have 4t minus 45 divided by 5, we have 9. So you have 9 equal to 0. This is a quadratic equation. Now let's solve this equation using the formula method. If we solve this equation using the formula method, we have that t is equal to minus b plus or minus square root of b squared minus 4ac all over what? 2a. Instead of using x here, we are using t. So if we substitute these values into this equation, don't forget a is the coefficient of t squared, b is the coefficient of t, and c is the constant. We have that t is equal to minus, our b here is -4, so we have minus 4 plus square root of, our b square here is what? -4 squared, so we have -4 squared minus 4ac, which is 4 times 1 times, our c is what? -9. All divided by 2a, which is 2 times our a is 1. We have that c is equal, minus times minus, we have plus, so we have 4 plus square root of -4. Don't forget this is all squared. -4 all squared will give us 16 minus 4 times 1 gives us 4 minus 4 times minus 9 gives us 36 divided by what? 2a. 2 here, our 2a is 2 times 1, which is the same thing as 2. We have t is equal to 4 plus root. Don't forget this has changed to positive. 16 plus 36 will give us what? 52 divided by 2. C is equal to 4 plus 52, square root of 52 to give us 7.211 divided by 2. 4 plus 7.211 will give us 11.211 divided by 2. 11.211 divided by 2 will give us 5.6. Therefore, the value of t is what? 5.6. T is equal to 5.6 seconds. The correct option here is option B, 5.6 seconds. Question 2 says, two resistors, 6 ohms and 9 ohms, are in parallel across a 36 volt battery. What is the total current from the battery? Option A, we have 6 amps. Option B, we have 8 amps. C, we have 10 amps. And D, we have 12 amps. So let's solve this question together. Solution. From the question, we are given two resistors, 6 ohms and what? 9 ohms. So we have R1 to be 6 ohms and R2 to be 9 ohms. They say they are connected in parallel across a 36 volt battery. So they give us voltage V to be 36 volts. They say what is the total current from the battery? Current, the total current, it's unknown. Now recall the formula for equivalent resistance. We have that equivalent resistance is equal to R1 R2 all over R1 plus R2. If we substitute this into this equation, we have that the equivalent resistance is equal to R1 times R2. Our R1 here is what? 6 ohms times R2. R2 is 9 ohms divided by R1 plus R2, which is 6 plus 9. 6 times 9 will give us 54 divided by 6 plus 9. 6 plus 9 will give us 15. Now we have 54 divided by 15. The equivalent resistance is equal to 54 divided by 15 gives us 3.6. Don't forget the unit for resistors is what? Ohms. We have gotten the resistance, but the question said we should find the total current. Total current, recall from Ohm's law. From Ohm's law, recall that the current I is equal to V over R. But the R we're going to use here is that of the equivalent resistance. So we have this. I is equal to V. From the question, V was given to be 36 volts. So we have 36 divided by the equivalent resistance, which is what? 3.6. 36 divided by 3.6 will give us what? 10. Therefore, the total current flowing through the battery is what? 10 amps. Therefore, I is equal to 10 amps. The correct option here is option C, 10 amps. Question 3 says, a metal has work function phi of 2.0 electron volts. You also have a light of wavelength 400 nanometer. Shines on it. Find the maximum kinetic energy of emitted electrons. A metal has work function of 2.0 electron volts. Light of wavelength 400 nanometer shines on it. Find the maximum kinetic energy of emitted electrons. Option A, we have 0.10 electron volts. B, 1.10 electron volts. C, 2.10 electron volts. And D, 3.10 electron volts. Now, solution, let's solve this question together. From the questions, we are given certain parameters. The first we have here is the work function. So we have the work function. The work function is equal to 2.0. The wavelength lambda is equal to 400 nanometer. We say find the maximum kinetic energy of the emitted electron. So maximum kinetic energy which is K max is unknown. Recall that photon energy E is equal to hc over lambda. From the question, we are given lambda, but we don't have h and c. So we have a shortcut to this. The photon energy is given as 1240 divided by lambda, which is in nanometer. From the question here, to get E is very simple because we are given lambda from the question. So if we substitute into this equation, we have that E is equal to 1240 divided by lambda. Lambda is what? 400. This divided by this gives us 3.10. The unit is EV, electron volts. We have gotten the value of EV now. To find the maximum kinetic energy, K max is equal to E minus the work function. To get the maximum kinetic energy is given by this formula, E, which is the photon energy, minus the work function. This is equal to our E from this solving is what? 3.10 minus The work function given from the question is 2.0. 3.10 minus 2.0 gives us 1.10. The unit is what? Electron volts. So the correct option here is option B, 1.10. Question 4 says a 0.50 kg mass on a spring has a period of 2.0 seconds. Find the spring constant K. Option A, 2.5 Newton per meter. Option B, 4.93 Newton per meter. Option C, 6.28 Newton per meter. And option D, 9.86 Newton per meter. This question is coming from the simple harmonic motion. That's where this question is coming from. From the question, we are given mass, right? A mass of what? 0.50 kg. That's the mass. We are also given period T to be what? 2.0 seconds. So we have period T to be 2.0 seconds. The question says find the spring constant K. So spring constant K is unknown. Recall from the formula for period of an oscillating body is given by this formula. T is equal to 2 pi square root of m over k, where m here is the mass and k is the spring constant. If we make k the subject of formula, because the question said we should make k the subject of formula, we should find k. So to find k, we have to make k the subject of formula, make it stand alone. The first step is to take the square of both sides. If we take the square of both sides, we have t squared is equal to 2 pi all squared root m over k all squared. We have taken the square of both sides. This 2 here takes away this square root. It cancels out. We're left with t squared is equal to 2 squared is 4 pi squared times, what do we have here? M over k. This is the same thing as t squared is equal to 4 pi squared m over k. If we cross multiply, we have t squared k, this will multiply this, is equal to 4 pi squared m. If we divide both sides by the coefficient of k, which is t squared, we have this will take away this, we're left with k. Therefore, k is equal to 4 pi squared m over t squared. Now we have made k the subject of formula, which is the spring constant. Let's impute these values into this formula to get the value for the spring constant. If we do that, we have k is equal to 4 pi squared. The value for m here is what? 0.50 divided by t squared is 2 all squared. K is equal to 4 pi squared times 0.50 divided by 2 squared is the same thing as 4. There's something common here, right? 4. 4 can take away 4. We're left with k is equal to pi squared times 0.50. Pi here is a constant for 22 divided by 7, which will give us 3.142 all squared times 0.50. K is equal to 3.142 squared will give us 9.87 times 0.50. K, which is the spring constant, is equal to 9.87 times 0.50. It will give us 4.93 Don't forget the unit for spring constant is Newton per meter. This is our final answer. Let's come to the option to pick the correct option. From the options here, the correct option is option B with 4.93 Newton per meter.